everyone, welcome back to my channel. In this video, we are going to study about some important concepts of congruences. First, let us understand the definition of congruences. Let m be a positive integer and a and b are any two integers. We say that a is congruent to b modulo m if m divides a minus b. So, a is congruent to b modulo m condition holds if m divides a minus b. So this is a definition of congruences where m be a positive integer and this a and b are any two integers. Symbolically we can write this definition as a is congruent to b mod m if m divides a minus b. Here a is congruent to b modulo m. We can write it as a is congruent to b mod m. Here the symbol says congruency. That is a is congruent to b mod m. This condition holds if this m divides a minus b. Let us take some example. That is 8 congruent to 3 mod 5. So this is a definition of congruence. So this is an example for an congruence because we can write this as 5 divides 8 minus 3. We know that 8 minus 3 is 5. Therefore, 8 congruent to 3 mod 5 is same as that of 5 divides 8 minus 3 is 5. Therefore, 5 divides 5 condition holds. Therefore, we can say that 8 is congruent to 3 mod 5. Similarly, take another example. 25 congruent to 3 mod 11. This is because 11 divides 25 minus 3. That is 11 divides 25 minus 3 is 22. We know that 11 divides 22. This is same as that of 22 divided by 11. 11 ones are 11 twos are. Therefore, 11 divides 22 holds. Hence, we can take this as 25 is congruent to 3 mod 11. Here congruency definition satisfies if m divides a minus b whole. Similarly, we can take this as 35 is not congruent to 4 mod 8. This is because here 8 does not divide 35 minus 4. Here we have to check the congruency, means we have to take a condition as we have to satisfy m divides a minus b. If this condition satisfies, then we can take this as a is congruent to b modulo m. Here 35 is not congruent to 4 mod 8. This is because 8 divides 35 minus 4. We get a value as 31. Therefore, we can conclude that we know that 8 does not divide 31. Therefore, we can conclude that 35 is not congruent to 4 mod 8. These are all some of the examples for congruences. Next, we shall see some of the important note on congruences. First one, if A is congruent to t mod 10 where t lies between 0 and 10. Here t is greater than or equal to 0 and t is less than 10. Then we can take this t as a last digit or unit digit in A. Here this is very important concept. They will ask in examination to find the last digit or unit digit of some value. For that, if A is congruent to t mod 10, here this unit digit or last digit satisfies the condition, that is t is greater than or equal to 0 and t is less than 10. For the modulo 10, we get an congruences, that is A is congruent to t mod 10. Then this t is a last digit or unit digit in A if this t is greater than or equal to 0 and t is less than 10. Using this condition, we can take a second note, that is any number of the form 3 power n can be expressed as one of the form of this, that is 3 power 4k, 3 power 4k plus 1, 3 power 4k plus 2 or 3 power 4k plus 3. Here they will give in examination to find the last digit or unit digit of the form 3 power some value. That is n may be anything, that is 3 power 15, 3 power 16, 3 power 20, 3 power 400, 3 power 700, n may be greater value. So to find the power of some greater value, it is very difficult to find the power of greater value. So we can apply this formula and we can easily find the value of last digit or unit digit of the values. Here any number of the form 3 power n, we have to express this 3 power n in the form of 3 power 4k, 3 power 4k plus 1 or 3 power 4k plus 2, or we can take it as 3 power 4k plus 3 and we get a congruences like this. That is for 3 power 4k, we get a congruences as here 3 power 4k is congruent to 1 mod 10. Similarly, the 3 power n can be expressed in 3 power 4k plus 1 form. Then we get an congruence like this, that is 3 power 4k plus 1 is congruent to 3 mod 10. For 3 power 4k plus 2, we get a congruence as 3 power 4k plus 2 is congruent to 9 mod 10. For 3 power 4k plus 3, you get a congruences as 3 power 4k plus 3 is congruent to 7 modulo 10. Here this are a very important note. You have to remember this note. That is, they will give one value, that is 3 power n. So we have to express, or we have to find the last digit or unit digit for this value. We can express 3 power n in any one of these form, that is 3 power 4k, 3 power 4k plus 1, 3 power 4k plus 2, or 3 power 4k plus 3, and we can easily find the congruences value. Here these four values you have to remember, that is 3 power 4k is congruent to 1 modulo 10, 3 power 4k plus 1 is congruent to 3 modulo 10, 3 power 4k plus 2 is congruent to 9 mod 10, 3 power 4k plus 3 is congruent to 7 modulo 10. Accordingly, we can take this as unit digit of any number of the form. 3 power n is one of 1, 3, 9 or 7. You will understand in a better way if we solve some problems. Just you have to remember any number of the form 3 power n can be expressed as 3 power 4k is congruent to 1 mod 10, 3 power 4k plus 1 is congruent to 3 modulo 10, 3 power 4k plus 2 is congruent to 9 modulo 10, and 3 power 4k plus 3 is congruent to 7 modulo 10. Here we can take the k value up to infinity. So we can check the values. Here if we take k value as 1, we get as 3 power 4 is congruent to 1 modulo 10. If we can check this value. Here we substitute k value as 1, we get as 3 power 4. We know that 3 power 4 is 81. So 81 is congruent to 1 modulo 10. This is because 10 divides 81 minus 1. 81 minus 1 is 80. So we can conclude that 10 divides 80. Or we can take this as here, if we take k value as 1, 4 plus 1 is 5. Therefore we get 3 power 5 value as 243. 243 is congruent to 3 modulo 10. This is because 10 divides 243 minus 3 is 240. We can easily find out 10 divides 240. This condition also holds. Here if we take k value as 1 means 4 plus 2 is 6. 3 power 6 value is 729. So we can take this as 729 is congruent to 9 modulo 10. This is because 10 divides 729 minus 9 is 720. Obviously 729 is divided by 10. So this also condition satisfies. Here this value, if we substitute k value is 1, 4 plus 3 is 7, 3 power 7 is 2187, which is congruent to 7 modulo 10. This is because 10 divides 2187 minus 7 is 2180. So we can take 10 divides 2180. So this congruence also satisfied. So we can take any number of the form 3 power n can be expressed as one of the way, that is 3 power 4k, 3 power 4k plus 1, 3 power 4k plus 2, 3 power 4k plus 3. Here we can take k value as 0 to infinity. So we get a congruences like this. 3 power 4k is congruent to 1 mod 10, 3 power 4k plus 1 is congruent to 3 mod 10, 3 power 4k plus 2 is congruent to 9 modulo 10, and 3 power 4k plus 3 is congruent to 7 modulo 10. Here any number of the form 3 power n can be expressed in any one of these form, not 3 power 4k plus 4, 3 power 4k plus 5, not like that. Here any number of the form 3 power n it can be expressed in only these four forms itself. Therefore, accordingly, unit digit of any number of the form 3 power n is one of the 1, 3, 9 or 7. This is about 3 power n form. In the similar way, any number of the form 2 power n can be expressed as one of the 2 power 4k, 2 power 4k plus 1, 2 power 4k plus 2 or 2 power 4k plus 3. That is, congruence form of this is like this. That is, 2 power 4k is congruent to 6 mod 10, 2 power 4k plus 1 is congruent to 2 mod 10, 2 power 4k plus 2 is congruent to 4 mod 10, and 2 power 4k plus 3 is congruent to 8 modulo 10. Here 6, 2, 4, 8 are the unit digit for the form 2 power n. So if we substitute any value of k, we can check the congruency. That is, if we in the place of k we can substitute as 1, we get as 2 power 4. We get a value of 2 power 4 is 16 is congruent to 6 modulo 10. This satisfies the congruency because 10 divides 16 minus 6 as 10, 10 divides 10. So in the place of k we can substitute it as 1, we get as 4 plus 1 as 5. Therefore 2 power 5 is 32, which is congruent to 3 mod 10 also satisfies because 10 divides 32 minus 2 is 30. Therefore 10 divides 30 congruency satisfies. Here also if we substitute as k value as 1, 4 plus 2 is 6. Therefore we get 2 power 6 value as 64 is congruent to 4 mod 10. Similar way, if we substitute k value as 1, 4 plus 3 is 7. That is 2 power 7 is 128, which is congruent to 8 mod 10. This is because 10 divides 128 minus 8 we get as 120. That is 10 divides 120 also satisfied. So any number of the form 2 power n which is expressed in one of these four forms, that is 2 power 4k, 2 power 4k plus 1, 2 power 4k plus 2 or 2 power 4k plus 3. So if we satisfies any four of the values, we can take a congruent method like this. So here 6, 2, 4, 8 are the unit digit for the form 2 power n. Therefore, we can conclude that unit digit of any number of the form 2 power n is one of these 6, 2, 4 or 8. So 6, 2, 4, 8 is nothing but a unit digit or last digit for the given form, that is 2 power n. In the similar way, any number of the form 5 power n, which is expressed in a congruence method as 5 power n is congruent to 5 mod 10 for all value of n. Here if we substitute any value of n, we get a unit digit value as 5. Therefore, we can conclude that unit digit of any number of the form 5 power n is 5. In the similar way, unit digit of any number of the form 6 power n is congruent to 6 modular 10 for all n. If we substitute any n value, we get a unit digit value as 6, because if we substitute n value as 2, 6 power 2, that is 6 square is 36, is congruent to 6 mod 10. If we substitute n value as 3, we get a value of 6 power 3 is 216, which is congruent to 6 mod 10. Hence, this congruency satisfies, that is 6 power n is congruent to 6 mod 10 for all value of n. Therefore, we can conclude unit digit of any number of the form 6 power n is 6. In the similar way, any number of the form 7 power n can be expressed as one of this form, that is 7 power 4k, 7 power 4k plus 1, 7 power 4k plus 2 or 7 power 4k plus 3, and the congruence method form as, that is 7 power 4k is congruent to 1 mod 10, 7 power 4k plus 1 is congruent to 7 mod 10, 7 power 4k plus 2 is congruent to 9 mod 10, and 7 power 4k plus 3 is congruent to 3 modulo 10. Here substituting k value and check the congruency. Therefore, we can conclude that the unit digit of any number of the form 7 power n is one of the form 1, 7, 9 or 3. This about the any number of the form 7 power n. In the similar way, any number of the form 4 power n. Here 4 power n we can write it as, here we know that 4 is nothing but 2 square. So, in the place of 4, we can substitute as 2 square. So, 4 power n we can express as 2 power 2n. And 2 power 2n is same as that of 2 power n. So, we have to express this value as like this. That is, any 2 power n can be expressed as any one of these form. In the similar way, the number of the form 8 power n also, we can take this as 8 is nothing but 2 cube. So, 8 power n we can express as 2 power 3 into n. So, 2 power 3 into n is same as that of 2 power n itself. So, we have to express 8 power n is also in the form of 2 power n. In the similar way, any number of the form 9 power n. 9 power n is nothing but 9 is nothing but 3 square. So, 9 power n is nothing but 3 power 2 into n. So, any number of the form 9 power n can be expressed as 3 power n. So, these are all very important note to solve the unit digit or the last digit of any number of the form 2 power n, 3 power n, 4 power n, 5 power n, 6 power n and 7 power n, 8 power n and 9 power n. So, let's solve some problems on this. Here is the first problem. Find the last digit of 7 power 2030. Here, we already discussed in a note that any number of the form 7 power n can be expressed as one of these four forms. That is 7 power 4k, 7 power 4k plus 1, 7 power 4k plus 2 or 7 power 4k plus 3. Here we have to observe that the last digit or unit digit of any number is nothing but we have to find the remainder for this value, that is 7 power 2013. When we divide this value by 10, that value is nothing but a last digit or unit digit for a given problem. But it is very difficult to find the remainder for the bigger value. Here 7 power 2013 we don't know the value. So we are using this method to find the remainder for the larger value. That is, here in this problem we have to find the last digit of 7 power 2013. So we have to remember any number of the form 7 power n can be expressed in any one of these forms. That is 7 power 4k, 7 power 4k plus 1, 7 power 4k plus 2 or 7 power 4k plus 3. So we can take 7 power 2013, we have to write in the form of 7 power 4 into some value. We have to find that value, then we have to apply the congruent method. So we can express this 7 power 2013 as 7 power of 4 into 503. Here in the calculator we can find 503 into 4, we get a value as 2012. So in the power we have 2013. So to achieve that value, we can take this as 7 power 4 into 503 plus 1. So this is of the form 7 power 4k plus 1. We have to find the remainder value. We already discussed in the note 7 power 4k plus 1 is congruent to some some value mod 10. So we can easily find the value, that value is 7. In the note we have already discussed 7 power 4k plus 1 is congruent to 7 modulo 10. This condition holds for all the value of k. So in the substitute we can check the value, that is if we can substitute in the place of k as 1, we get as 7 power 4 plus 1 is 5. So we get a value of 7 power 5 as 16,807. We can take this as 16,807 is congruent to 7 mod 10. That is 10 divides 16,807 minus 7 means we get a value of 16,800. So we can easily find out that is 10 divides 16,800. So this congruence value satisfies for all the value of k. So we can take this as 7 power 4 into 503 is 2012 plus 1. We can take this as this is congruent to 7 modulo 10 easily. Therefore we can conclude that this 7 is a last digit or unit digit for the value 7 power 2013. This is very important problem. So we have to solve this type of problem in this method only. Take second problem. Find the unit digit of 6 power 254. Here finding unit digit or last digit is both are same. Here they have mentioned you have to find the unit digit of 6 power 254. So this is also a greater value. So to find the last digit or unit digit for this value means you have to apply the formula, that is we know that we already discussed in a note, any form of the type 6 power n that is congruent to 6 mod 10 for all value of n. Here we can substitute n value as 1, we get a 6, that is 10 divided 6 minus 6 is 0, that is 10 divided 0. If we take this value as 2, we get as 6 square, that is 6 square is 36 is congruent to 6 modulo 10, that is 10 divided 36 minus 6 is 30. Therefore this satisfies for all the values of n. So we can take 6 power n is congruent to 6 modulo 10 for all value of n. Here in the place of n we have 254. Therefore with this formula we can substitute as 6 power 254 is congruent to 6 modulo 10. This implies 6 is a last digit of 6 power 254. This completes the problem. These are all very important problems. So here we have to remember the form, that is here this first problem is of the form 7 power n. So we have to apply the congruence value as 7 power 4k plus 1 is congruent to 7 modulo 10. Here 7 is the last digit. Here this is of the form 6 power n. So we have to apply formula, that is 6 power n is congruent to 6 modulo 10. Therefore we can conclude 6 power 254 is congruent to 6 modulo 10. Therefore we can take this 6 is a last digit for the value 6 power 254. Observe in the problem we have to take a formula and simplify the values. Next problem, find the last digit of 8 power 205. Here we have to find the last digit for the value 8 power 205. Here we have to observe that we already discussed the number of the form 8 power n. We can write this as 2 power 3 into n. This is because we can write 8 as 2 cube. So we can take this as 2 cube into n is 2 power 3 into n. So any value of the form 8 power n we can write it as 2 power 3 into that value n. So take the value, that is 8 power 205, we can write it as 2 power 3 into n is 205 here. We can take this as 2 power 3 into 205 is 615. So we get the value as 2 power 615. Therefore we have to find the last digit for the value 2 power 615. Here they asked to find the last digit for 8 power 205, but we can express 8 power n as the form 2 power 3 into n. So substituting n value here we get a value as 2 power 615. Therefore we have to find the last digit for 2 power 615. Here also we have discussed any number of the form 2 power n can be expressed as one of the form, that is 2 power 4k, 2 power 4k plus 1, 2 power 4k plus 2 or 2 power 4k plus 3. So take the value, that is we have to substitute 2 power 615 as 2 power 4 into some value. We have to check what value is this, that is 2 power 4 into, in the calculator we can take, that is 153 into 4 as 612, but we get a value which is equal to 615 or nearly equal to 615. So if we multiply 4 with 153 we get a value of 612. So here in the problem they have given, we have to find the 2 power 615. Here we get a value of 612. So we have to add the value 3. So that we get a value as 2 power 4 into 153 plus 3. 4 into 153 plus 3 we get a value of 615. So we get a 2 power n we can express in the form as 2 power 4k plus 3. Therefore we get a unit digit as, here we already discussed 2 power 4k plus 3 is congruent to 4 modulo 10. Therefore 2 power 615 we can express as 2 power 4k plus 3 where k is 153 here. Therefore, we can take this as in a congruent way as 2 power 4 into 153 plus 3 is congruent to 4 modulo 10. Therefore, we can take this as here this 4 is nothing but a remainder obtained when we divide 2 power 615 with 10. Therefore, we can conclude that 4 is a last digit of 8 power 205. This completes the problem. These are all the problems on finding last digit for the values from 2 power n to 9 power n. We shall move on to another problem. Find the last digit of 13 power 37. This is nothing but we have to find the remainder value when 13 power 37 is divided by 10. So we have to find the remainder value when 13 power 37 is divided by 10. So to achieve this congruency, first step we have to take this value as that is 13 is congruent to 3 modulo 10. This is because we can write this as 10 divides 13 minus 3. 13 minus 3 is 10. So obviously 10 divides 10, this value satisfied. Call this as equation number 1. Next step, here we have to achieve this as 13 power 37. Here in the left hand side we have 13 power 37. So we have to raise some power so that we have to obtain the value that is 13 power 37 in the left hand side. For that, first squaring on both the side we get as, here we square this value, we get as 13 square is congruent to 3 square modulo 10 as it is. Here 13 square is congruent to 3 square mod 10. That is 13 square is congruent to 3 square is 9 modulo 10. Here in the left hand side we have 13 square. If we raise some value so that we can take it as 13 power 37, in the right hand side we get a bigger value. That is if we raise the power as 2 into some value, that is if we raise the power as 18, 18 into 2 is 36. In the left hand side we get as 13 power 36, but in the right hand side we can take it as 9 power 36. We get a greater value. So to reduce that method, in next step we can take this as, here 9 is congruent to minus 1 modulo 10. This is because 10 divides 9 minus of minus 1 is plus 1. Therefore 10 divides 10. So in the place of 9 we can write it as minus 1. So these are all the properties of congruences. We can square the values, some values. The congruency is same. Here also if we take this 9 as, 9 is congruent to minus 1 modulo 10. This is because 10 divides 9 plus 1 is 10. So 10 divides 10 satisfies. So in the place of 9 we can write it as minus 1 because this both congruency are same. Therefore we can write it as 13 square is congruent to, in the place of 9 we can write it as minus 1 modulo 10. So in the next step we have to raise the power of 18 on both the sides. That becomes 13 power. Here raising the power of 18 means 2 into 18 in the left hand side, that is 13 power 2 into 18, which is equal to, here 2 into 18 is 36, that is 13 power 36 is congruent to minus 1 power 18 modulo 10. Here 13 power 2 into 18 is nothing but 13 power 36 is congruent to minus 1 power 18 modulo 10. Call this as equation number 2. Here equation 1 is 13 is congruent to 3 modulo 10. Here equation 2 is 13 power 36 is congruent to minus 1 power 18 modulo 10. So we can multiply the left hand side and right hand side separately. We get as, that is multiplying equation 1 and equation 2, we get a value as, the left hand side we get as, here equation 1 is 13 and equation 2 is 13 power 36. If you multiply, that is 13 power 36 into 13 is congruent to, here equation 1 is 3 and equation 2 is 1. So in the right hand side we get 1 into 3, that is modulo 10. Under modulo 10 we are getting values like this. Next step, here bases are same, adding the power, that is 36 plus 1 is 37. We get in the left hand side 13 power 37, which is congruent to 1 into 3 is 3 modulo 10. Therefore we get a remainder as 3 when we divide 13 power 37 by 10. Therefore we can conclude that 3 is a last digit of 13 power 37. So this completes the problem. Here our aim is to find the remainder when the 13 power 37 is divided by the value 10. So to achieve that value, first we have to consider 13 is congruent to 3 modulo 10 and raising some values, we get in the left hand side 13 power 37 which is congruent to some value. That value is nothing but a last digit of the given problem. This completes the problem. We shall move on to another problem so that you can understand in a better way. Find the last digit of 17 power 7. Here our aim is to find the congruence of, that is 17 power 7 is congruent to some value under modulo 10. So that value is nothing but a last digit for the value 17 power 7. So to achieve that, first take 17 congruent to 7 modulo 10. This satisfies because 10 divides 17 minus 7 is 10. Therefore obviously 10 divides 10. Therefore, this congruency satisfies. Call this as equation number 1. Next step, squaring on both the side of the congruence we get as 17 square is congruent to 7 square modulo 10. Next step, 17 square is congruent to 7 square is nothing but 49 modulo 10. In the previous problem, as same as that, here in the left hand side we have 17 square. So we have to raise some value so that we can take this as 17 power 7. But in the right hand side, if we raise the power, we get as 49 power some value, that is larger value we get. Therefore, to reduce that, we can write it as here 49 is congruent to 9 modulo 10. So in the place of 49, we can write it as 9. Therefore, in the place of 49, we have to substitute as 9. We get as 17 square is congruent to 9 modulo 10. In the left hand side, that is 17 square. Next step, we have to raise the value so that we get a value of 17 power 7 or which is nearly equal to 17 power 7. So we have to raise some values so that we get a value of 17 power 7 or nearly equal to 17 power 7. Before that, in the right hand side, we have 9. Therefore, we raise a power so that with a larger value. So to reduce that, we can write in the place of 9 as, here we have 9 is congruent to minus 1 modulo 10, that is 10 divides 9 plus 1 is 10. Therefore, in the place of 9, we can substitute as minus 1, that is 17 square is congruent to minus 1 modulo 10. Now we can raise the power of 3. Here raising the power of 3 on both the side, we get 17 power 2 into 3 is 6, that is 17 power 6 is congruent to minus 1 power 3 modulo 10. Here minus 1 power 3, that is odd power we get, that is we get a value as negative value, that is 17 power 6 is congruent to minus 1 modulo 10. Here we have 17 power 7. So we have to multiply this value and this value, we get a value 17 power 7. In the right hand side we have negative value. So to reduce that value, here minus 1 is congruent to 9 modulo 10. Therefore in the place of minus 1 we can substitute as 9, that is minus 1 is congruent to 9 modulo 10. This is 10 divides minus 1 minus 9 is minus 10. 10 divides minus 10 also satisfies. Therefore in the place of minus 1 we can substitute as 9, that is 17 power 6 is congruent to 9 modulo 10. Call this as equation number 2. Next step, we have to multiply equation 1 and equation 2. We get as, here we have to multiply the left hand side of congruence and right hand side of congruence separately, that is 17 power 6 into 17, which is congruent to 7 into 9 modulo 10. Here in the left hand side the bases are same. If we add the power, we get as 17 power 6 plus 1 is 7 is congruent to 7 into 9 is 63 modulo 10. So we get a remainder value which is greater than 10. So to reduce that to a value that is lesser than 10, we can write this as 63 is congruent to, we know that 63 is congruent to 3 modulo 10, that is 10 divides 63 minus 3 is 60. Therefore we can write it as 63 as 3, that is 17 power 7 is congruent to 3 modulo 10, because 63 we can write it as 3. Therefore we can conclude that 3 is the last digit of 17 power 17. This completes the problem. We shall move on to another problem. Find the remainder when 7 power 200 is divided by 23. Till here we studied the values, that is we have to find the last digit or unit digit for some value. In that case we have to divide the value by the modulo 10, that is we have to divide the value by 10. But in this problem they have mentioned we have to find the remainder when the value, that is 7 power 200 is divided by 23. That is by given data we have to find the remainder value when the value, that is 7 power 200 is divided by 23, that is modulo 23. Here then we have to find this congruence, that is 7 power 200 is congruent to some value modulo 23. So to find this value, first take, we know that 7 square is congruent to 3 modulo 23. This is because 7 square is nothing but 7 into 7, that is 49, is congruent to 3 mod 23, that is 23 divided by 49 minus 3 is 46. We already know that 23 is divides 46. Therefore this congruence holds. Therefore we can take this as 7 square is congruent to 3 modulo 23. Call this as equation number 1. Next step, we have to write some value so that we can take in the left hand side as 7 power 200, which is congruent to some value which is divided by, that is modulo 23. So cubing on both the side we get as, in the left hand side we get as 7 square whole cube congruent to 3 cube mod 23. Here 7 power 2 into 3 is 6 is congruent to 2 cube is nothing but 27 modulo 23. So next step we have to take this value which is less value so that we can cube or raise the power so that we get a smaller value. So we can write this as 27 is congruent to 4 mod 23. That is 23 divides 27 minus 4. 27 minus 4 is 23 itself. Therefore 23 divides 23. Therefore we can substitute in the place of 27 as 4. We get as 7 power 6 is congruent to 4 mod 23. Next we have to squaring on both the side of this congruence. We get as here 7 power 6 into 2 is congruent to 4 square mod 23. Here 6 into 2 is 12. Therefore the is 7 power 12 is congruent to 4 square is 16 mod 23. Here we are taking this value so that we have to achieve the value that is 7 power 200. First step we have to take the congruence, that is 7 square is congruent to 3 mod 23. Next cubing on both the side we get this as 7 power 6. Next you have to square on both the side, we get a 7 power 12 is congruent to 16 mod 23. Here in the right hand side we have to get a smaller value so that we can write this 16 is congruent to minus 7 mod 23. That is 23 divides 16 minus into minus plus 7. 16 plus 7 is 23. Therefore we get 23 divides 23. Therefore in the place of 16 we can write it as minus 7. That is 7 power 12 is congruent to minus 7 mod 23. Here if we multiply the power by 18 we get a value which is close to 200. So to achieve that value we can split this 7 power 12 as 7 power 11 into 7 power 1. 7 bases are same. If we add the power, that is 7 power 11 plus 1 is 12. Therefore we can split this 7 power 12 as 7 power 11 into 7 power 1 is congruent to minus 7 power 1 modulo 10. We can cancel the 7 power 1, 7 power 1. The remaining is 7 power 11 is congruent to minus 1 modulo 23. Next step we have to raise the power of 18 on both the side. We get as here 11 into 18 we get a value as 198 which is close to 200. So to achieve that value we have to raise the power of 18 on both the side. We get as 7 power 11 into 18 which is equal to 7 power, here 11 into 18 is 198 which is congruent to minus 1 power 18. Here we have the even power, therefore we get a positive value, that is plus 1 modulo 23. That is 7 power 198 is congruent to 1 mod 23. Call this as equation number 2. Next step we have to multiply equation 1 and equation 2. We get as equation 1 is 7 square is congruent to 3 mod 23. Equation 2 is 7 power 198 is congruent to 1 mod 23. Therefore we get 7 square into 7 power 198 congruent to 3 into 1 mod 23. Here in the left hand side the bases are same. If we add the power we get as 7 power 2 plus 198 is 200 is congruent to 3 into 1 is 3 mod 23. Therefore we can conclude that 3 is a remainder when 7 power 200 is divided by the value 23. This completes the problem. We shall move on to another problem. Find the least positive remainder when 2 power 301 is divided by 5. Here we have to find the remainder value, that is least positive remainder is nothing but remainder value when the value 2 power 301 is divided by 5. Therefore we have to find a congruence like this, that is 2 power 301 is congruent to some value mod 5. So to achieve this value, first take 2 power 4 is congruent to, here 2 power 4 is nothing but 16 which is congruent to 1 mod 5 because 5 divides 16 minus 1 is 15. 5 divides 15 satisfies. Therefore we can take this as 2 power 4 is congruent to 1 mod 5. Next step we have to raise the values so that we can take a values that is which is approximately equal to 301. If we raise the power of 75 for this congruence we get as 2 power 4 into 75 which is congruent to 1 power 75 mod 5. Here 75 into 4 is nothing but 300. So 2 power 300 is congruent to here 1 power 75 is nothing but 1 mod 5. So we get a value as 2 power 300 is congruent to 1 mod 5. Here we have to find the 2 power 301. So to achieve that value we have to multiply throughout this congruent by 2. We get as, that is 2 power 300 into 2 is congruent to 1 into 2 mod 5. Therefore here in the left hand side here the bases are same. If we add the values we get as 2 power 300 plus 1 is 301 is congruent to 1 into 2 mod 5. Therefore we get a remainder 2. Therefore we can conclude that 2 is a least positive remainder when 2 power 301 is divided by 5. This completes the problem. Here these are all very easy problems. One thing we have to remember that we have to take this congruent value so that we can raise the power and we get a value which is given in a problem. That's a very important step. We shall move on to another problem. Find the remainder when 7 power 118 is divided by 10. Here we have to find the remainder value when 7 power 118 is divided by the value 10. Here first take that that is 7 square is congruent to 9 mod 10. This is because 7 square is 49, which is congruent to 9 mod 10 means 10 divides 49 minus 9 is 40. Obviously 10 divides 40, so we can take this as 7 square is congruent to 9 modulo 10. Next step, here if we raise this power, we get a value in the right hand side, we get a value which is greater values. That is, to reduce that, we have to substitute in the place of 9 as minus 1. That is, 9 is congruent to minus 1 mod 10, that is 10 divides 9 plus 1 is 10, 10 divides 10. So in the place of 9, we can substitute as minus 1. Therefore, 7 square is congruent to minus 1 mod 10. Here we raise the power of 59 on both the side, we get as 2 into 59 as 118. So we have to raise the power of 59 on both the side, we get as 7 square into 59 is congruent to minus 1 power of 59 modulo 10. Here in the left hand side we have 7 power 2 into 59 is 118, which is congruent to, here this is negative because here we have odd power, therefore we get minus 1 mod 10. Next step, we have to reduce this to a positive value, we can take this as minus 1 is congruent to 9 modulo 10, this satisfies. So in the place of minus 1 we can substitute as 9, therefore we get 7 power 118 is congruent to 9 modulo 10. Therefore we can conclude that 9 is a remainder when 7 power 118 is divided by 10. This completes the problem. We shall move on to another problem. Find the remainder when 2 power 1000 is divided by 13. Here we have to find the remainder value when 2 power 1000 is divided by the value 13. So we have to achieve the congruency like this. So to get this value, first take 2 power 6 is congruent to minus 1 mod 13. This is because 2 power 6 is 64. That is 13 divides 64 minus into minus plus 1. Therefore we get 13 divides 64 plus 1 is 65. Obviously 13 divides 65. Therefore we can take this as 2 power 6 is congruent to minus 1 mod 13. Next step, we have to raise the power of 166 on both the side. We get, here we have to raise the power of 166. We get 6 into 166. We get a value 996, which is nearly equal to 1000. So this is a very important step. That is, raising the power means you have to take the values such that if we multiply that value with the given value, that is, or we have taken the value so that we get a value which is nearly equal to the power value. Here we have raising the power of 166 on both the side, we get 2 power 6 into 166, which is congruent to minus 1 power 166 modulo 13. Here 2 power 6 into 166 is 996 is congruent to 1 mod 13. Call this as equation number 1. Also we know that here we have 2 power 996. Therefore we are taking, that is 2 power 4 is congruent to, here 2 power 4 is nothing but 16. 16 is congruent to 3 mod 13. This is because 13 divides 16 minus 3 is 13. 13 divides 13. Therefore, we have to take 2 power 4 is congruent to 3 mod 13. Take this as equation number 2. From equation 1 and equation through, multiplying equation 1 and equation through, we get as 2 power 996 into 2 power 4 is congruent to 1 into 3 mod 13. Here, doing this procedure, we get a value as 2 power 996 is congruent to 1 mod 13. Call this as equation number 1. Here, we have to obtain 2 power 1000. For that, we have to take a value, that is 2 power 4 remaining. Therefore, we have taken as 2 power 4 is congruent to 3 mod 13. Under 13, 2 power 4 is 16 minus 3 is 13. Therefore, 13 divides 13. Therefore, we get a congruency as 2 power 4 is congruent to 3 mod 13. From equation 1 and equation 3, we can multiply both the equation. We get as 2 power 996 into 2 power 4 is congruent to 1 mod 1 into 3 mod 13. Therefore, in the left hand side, the bases are same. If we add the power, we get as 2 power 996 plus 4 is 1000 is congruent to 1 into 3 is 3 mod 13. Therefore, we can conclude that 3 is a remainder when 2 power 1000 is divided by 13. This complete the problem. Here we can take any value so that finally we get a value which is congruent to some value, that is mod under mod 13. Therefore, here we get a remainder as 3 when 2 power 1000 is divided by 13. This completes the problem. We shall move on to another problem. Find the remainder when 175 into 113 into 53 is divided by 11. Here they have given a problem in a different way. That is, here they have given a product of 3 values. We have to find the remainder for this product of 3 values which is divided by the value 11. For this value, we have to find a remainder means we have to first find the remainder for 175, 113 and 53 which is separately which is divided by 11. Here by the normal method we have to find a remainder for 175 for 11. That is, we have to divide 175 by 11. By fraction method we get as, here 175 is dividend, 11 is a divisor. We have to find quotient value and with the help of quotient we get a value as remainder. So we get as, here if we multiply 11 with 15 we get as, here 11 into 15 is 165 which is close goes to 175. Therefore 11 into 15 is 165. Next step, we have to subtract 175 by 165. We get as 10. This is a remainder. So 175 is dividend, 11 is a divisor, 15 is a quotient, and 10 is a remainder. So if we divide 175 by 11, we get a remainder as 10. So we can conclude that 175 is congruent to 10 mod 11. Here if we divide 175 by 11, we get a remainder as 10. So we find a remainder for 175 when we divide this by 11. In the similar way, we have to find the remainder for 113 if we divide this 113 by 11. So we have to take like this. We have to divide 113 by 11. We get as here 11 into 10 is nothing but 110, which is nearly equal to 113. Next step, we have to subtract 113 by 110. We get a value as 3. So we get a remainder as 3. Therefore we can write in a congruence form as 113 is congruent to 3 mod 11. Here 3 is a remainder, is obtained when 113 is divided by 11. In the similar way, we have to find the remainder for 53 when it is divided by 11. So we can take this as, you have to divide 53 by 11. Here we have 11 into 5 is 55, which is greater than 53. So 11 into 4 we have to take. 11 into 4 is 44. 53 minus 44 is remaining is 9. Therefore this is a remainder. Therefore we can conclude that 53 is congruent to 9 modulo 11. So they are given, we have to find the remainder for the product of 3 values, which is divided by 11, means you have to find a fraction method for all the 3 value. Then we obtain a congruent value as 175 is congruent to 10 mod 11, 113 is congruent to 3 mod 11, and 53 is congruent to 9 mod 11. Once we obtain the 3 congruent for the 3 value, next step we have to multiply these 3 congruent. That is left side we have to multiply. It's congruent to right side of the value, that is modulo 11. That is 175 into 113 into 53 is congruent to, here the remainder value of 175 is 10, and remainder value of 113 is 3, and remainder value of 53 is 9. Under modulo 11, which is congruent to, here 10 into 3 into 9 is 270. Under modulo 11, here we have to obtain this remainder value, that is least remainder value we have to get. Therefore we can take, here we know that 270 is congruent to 6 modulo 11. Here 11 divides 270 minus 6 is 266. Therefore we can take in the place of 270 as 6. We get as 175 into 113 into 53 is congruent to 6 modulo 11. Therefore we can conclude that 6 is a remainder for 175 into 113 into 53, which is divided by 11. This completes the problem. These are all different methods, that is, see, they have given a product of 3 value. Here we have to find the remainder when it is divided by some value. That means we have to find the remainder for all the 3 value, and we have to obtain a congruent value. Next we have to multiply this 3 congruent value. We get a remainder value, that is 6 is a remainder for the value 175 into 113 into 53, which is divided by 11. This completes the problem. Next we shall move on to another problem. Find the remainder when 349 into 74 into 36 is divided by 3. These are all very important problems. Procedure same as before. Here we have to first find the remainder for 349 and for 74 and for 36 separately, which is divided by 3. First you have to divide 349 by 3. We get as, here we have to take a quotient as 116. If you multiply 116 with 3, we get a value as 348, which is nearly equal to 349. Next step we have to subtract 349 by 348. We get a value as 1. So the 1 is a remainder. Therefore we can take it in a congruent method as 349 is congruent to 1 mod 3. In the similar way, we have to find the remainder for 74 when it is divided by 3. So we get a quotient as 24. Here 3 into 24 we get a value of 72. If we subtract 74 by 72, we get a remainder as 2. Therefore we can take it in a congruent method as 74 is congruent to 2 mod 3. Similarly, you have to find the remainder value for 36 when it is divided by 3. We get a value as, that is quotient is 12. 3 into 12 is 36. 36 minus 36 we get a value as 0. Therefore 0 is a remainder over here. Therefore we can conclude that this is a 36 is congruent to 0 mod 3. Next step we have to multiply these 3 congruency. We get as 349 into 74 into 36 is congruent to 1 into 2 into 0 mod 3. Here in the right hand side we get a value 0. Therefore we can conclude that 349 into 74 into 36 is congruent to 0 mod 3. Therefore we can conclude that 0 is a remainder for 349 into 74 into 36 when it is divided by 3. This completes the problem. So till here we studied so many problems on finding last digit digit or unit digit of some value, and to find the remainder of the value which is greater values which is divided by some value, and in this is of the form we have to take a remainder, or we have to find the remainder for the product of some value which is divided by the value which is given in the problem. So these are all very important problems to be remembered. In next video we study about linear congruences and problems on linear congruences. Thank you.